Hello, welcome everyone. Thank you for joining us for the Lazy Developer's Guide to Observing Your Own Code. We're very excited to be here. This is our first time in Athens, first time in a Devoxx conference, and our first time speaking together. My name is D.Todea A.Villela. I am a CNCF ambassador. I'm also a blogger, podcaster, and one of the maintainers of the OpenTelemetry end user SIG. I'm also one of the OpenTelemetry community managers. I spend my life in observability and OpenTelemetry as a principal developer advocate at Dynatrace, and by night I like to climb walls. I checked out one of the local bouldering gyms here in Athens when I arrived on earlier in the week, and I also love capybaras because they make me happy.
Kalispera, my name is D.Todea. I'm a DevRel engineer at Victoria Metrics by day, and also by day I'm an OpenTelemetry docs triager. I help organize the Cloud Native Days Romania, which is in May 18-19 in Bucharest. And yeah, I love foreign languages and I like to pick up a few words in Greek.
So we are here to talk to you about observability for developers, especially. My background is actually as a Java developer. I started learning Java in my university years around 1998, 1999. I spent 16 years as a Java developer, and I remember when I started my career, development was very different. I am of the age of, J2EE. Java 2 was becoming the big thing at the time. And now developers are expected to know so many more things. We are expecting them to shift left on so many things. And now we're saying, hey, shift left on observability, which is absolutely irritating because you're like, now another thing for me to shift left on, especially if it seems that we're saying, hey, you have to instrument your code for the benefit of the SREs. So really, what's in it for me? So what is in it for me?
Well, you get a bunch of things. Why observability matters? Well, actually, yeah, it matters because it reduces the debug time. So yeah, because nobody loves to spend time troubleshooting hours and hours. I used to work as a dev senior SRE, so I know that time is super, super important. It accelerates development and deployment. So yeah, faster debugging time means that we get actually to ship faster, like the features in production. And also it improves the code. So instrumenting actually helps us because it can expose the slow pass or the latency or weird edge cases. So yeah, definitely we need that before we ship the code into production. And it helps us understand the distributed systems. Nowadays, we work with microservices that are like everywhere. And yeah, there are many moving parts that we need to understand, and observability helps us with this to understand what's going on between the services, within the services.
But, as a developer, I'm like, okay, but how can I use observability to troubleshoot my code without a lot of effort? Because I am a little bit lazy. I like to automate as many things as possible, and while still being effective, right? We've seen these benefits. So how can we leverage them? But before we do that, we're going to get into some basic concepts around OpenTelemetry and observability. Now, hands up if you've heard of observability, first of all. Right on. Amazing. Now, I know there's like different definitions of observability out there. We're going to, this is just a very brief overview, so we're all on the same page. But my favorite definition of observability is actually from my friend, Hazel Weekly, and she says that observability is the ability to ask meaningful questions, get useful answers, and act effectively on what you've learned, which I think is such a great definition and applies whether you're a developer, an SRE, or a QA at looking and understanding your code and why it's behaving that way.
So I really like that definition. Actually, I come across observability as an SRE a lot, and there used to be like this concept of observability as having 3 pillars, obviously based on the signals, traces, logs, and metrics. But to be honest, this is quite outdated. Then afterwards, it came the idea of observability as a braid. That was around 2021, and Ted Young actually wrote an article about that, that will look at observability signals as linear. So the braid actually implies structure and predictability, and each strand follows a path, and their intersections are fixed. However, this doesn't really sound like the current, state of observability that we have at the moment. Instead, we should look at observability as a mesh, right? So as a network. The relationships between components and services are a lot more dynamic. So they literally intersect with each other, and the components communicate with each other a lot. So for example, take a service A that emits traces, and the traces can reveal latency in another service. They will also trigger an alert, and the alert will modify the sampling, and that in return will affect the service A behavior. So indirectly, service A will modify the service B behavior through the observability system. So we really need that observability data. If we have no observability data, then we cannot ask questions about our systems, and obviously we cannot answer whatever we are seeing when it comes to the errors. But luckily, we have OpenTelemetry to help us with that. So what is OpenTelemetry? By now, I think many of you know what OpenTelemetry, even instrumented a lot of applications with it. So OpenTelemetry is a project of the Cloud Native Foundation, Cloud Native Computing Foundation, open source, vendor-neutral observability framework for instrumenting, generating, collecting, and exporting telemetry data.
And OpenTelemetry is made up of some important components that we'll quickly go over. So first of all, we have the semantic conventions, and you can think of them as labels for your telemetry, standard labels. Just like your food, you have labels. When you go to the supermarket, you have labels, standard labels showing like sugars, carbohydrates, fats. You can think of semantic conventions as that. We also have the OpenTelemetry API and SDK. Now, the API is basically the entry point for your telemetry. It defines the methods of instrumentation, and there's an API for each language supported by OpenTelemetry, including Java. And then the SDK is the implementation of the API. So if the API is the what, the SDK is the how. And again, there are SDKs for each language supported by OpenTelemetry. Then we have OTLP, because we need a way to transport our telemetry data, and that's OTLP. That's the OpenTelemetry protocol. And then finally, my very favorite component of OpenTelemetry, which is the OpenTelemetry collector, also known as the Swiss Army knife of OpenTelemetry. And it basically has the following components. It has receivers so that you can ingest the data from multiple data sources, whether it's application or infrastructure. It also has processors, so you can transform your data. You can add and remove labels. You can mask your data. You can batch your data. And then we have exporters that send your data to one or more destinations so that you can use them for analysis. So that can be standard out. It can be your favorite OpenTelemetry backend, anything like that. And then it has some additional components called connectors and also extensions.
Right, so we were talking about earlier about the signals. What will be the OpenTelemetry signals? At the beginning, we have the signals, so basically anything that will give us the data. Important traces are tracking the journey of a request or transaction across different services and dependencies, and they highlight bottlenecks and the flow. And the trace usually consists of spans representing specific operations. Then we have the metrics, good old metrics, that they measure system characteristics like CPU, usage, error rates, or request latency. Then we get the logs that can be structured or unstructured, and there are timestamp messages that are emitted by a service or a component. It is important to use logs because it will give us some information about what happened at a specific time. And newer to the game are the profiles that deliver detailed time-based insights into both application and system behavior. And they show us how code infrastructure consume resources. And basically, they are different from, let's say, if you think about the other three signals that show us what is happening, basically profiles explain why is happening. So they are actually a critical pillar to the modern observability. So yeah, we are talking about shifting left to the developers. They get to actually to shift left more and more often, and every month there's something new to shift left on. So it's really a lot of things. But now we're also adding instrumentation to the game. So basically, what is instrumentation is the process of telemetry, of adding telemetry to your application or infrastructure. So there are two flavors: the zero code or auto instrumentation, that basically adds the instrumentation for you without touching your own code, or the manual instrumentation. And then, yes, you will be required to add your traces, metrics, and logs to your own code.
And I will add also that in terms of the auto instrumentation, that's not available for every language, but it is available for Java, .NET, Go, PHP, Python, and JavaScript. Now, in terms of instrumentation, we want to make sure that it is meaningful to us, right? If we're going to bother to instrument our code, let us make it work for us. And in order to do that, we want to ensure that our instrumentation is not only meaningful, but relatively low effort. Now, as part of that, Diana actually went out and spoke with a number of developers out there to get their feel for some of the friction points, shall we say, around instrumenting code with OpenTelemetry.
Sure. So basically, there were a lot of sincere opinions out there, and this is what I liked about it. One of the opinions were, we are dependent on the efforts of the specific SDK community, because, like Adriana said, you get all these different SDKs, and being an open source project, every community has a different levels of maturity. So obviously, Java or Python can be way more advanced than Rust, for example, right? So it's important for developers to know what kind of SDK to pick when they're instrumenting, and be very careful about the advances in that particular community. Also, if there's no auto instrumentation, then we really have a hard time manually instrumenting, right? Because you have like Java, .NET, Python, JavaScript, PHP, right, and Go that have support for auto instrumentation, but then the others are left somewhere in the dark ages. But yeah, meaning that for manual instrumentation, you are dependent of the documentation, and you really need to go down there and really search for other example or use cases from other developers. Then there's way too many options in instrumenting. So you have SDKs, eBPF, compile time, okay, and also the projects are not really mature enough. And that can be very challenging for developers. Also, like in terms of tech points, you have some public API stability. Then when you upgrade the project, dependency can be painful. Also, the instrumentation is too verbose, or the metrics cardinality is a big problem for the high cardinality attributes. So there you go. There's a lot of opinions out there, and the pain points are real. Also, for some developers, the same kind of pain points can actually become a positive point, right? So it's not really black and white. I mean, OpenTelemetry, sometimes it's always also like appreciated from its flexibility, extensibility point of view, right? Because of this flexibility, it's highly customizable and provides a lot of helpers with different metric exporters. So there you go. Knowing that we have so many positive points and pain points, what are some good tips for developers to start instrumenting?
Yeah, absolutely. So when you are starting to instrument your code, first of all, instrument as you go. And this is really important. It can be really overwhelming when you start instrumenting your code, especially if it's an older application that doesn't have any instrumentation. You're basically adding technical debt to your code, right? Because you are having to add code to instrument your code so that you can debug it. So put all that aside and think, you know what? let me instrument any of my new code as I go along. Think of it as like if you're doing test-driven development, you're writing your tests as your code, or you're writing comments as you code. Think of, and this is known as observability-driven development, where you're instrumenting your code as you go. The other thing is start with zero code instrumentation. Fortunately, Java actually has a very robust community. And when it comes to OpenTelemetry, I would say it's probably one of the most mature languages in terms of the API and SDK support and auto instrumentation. So you really have, I would say, really good support around auto instrumentation, and is such a great way to get started because effectively you don't have to touch your code. You start the Java agent, set up some parameters, and boom, you're good. But it doesn't cover everything because what it does, it instruments some common libraries and frameworks in Java, but it won't node instrument everything. And for that, you need to supplement with your manual instrumentation. And then finally, I would say don't be afraid to use AI to help you instrument. And I'll get a little bit more into that later on.
Sure. So yeah, what to instrument, right? So we can focus on the signals. Like yeah, as developers, yeah, we do care about the path that the request took from point A to B. So the traces and what happened along the way, the logs, metrics wise, we do care about different metrics like latency. You know, why a particular request took longer than usual. Also, we need to keep in mind why, so this is where the logs come forward, because they can help us capture errors, validation failures, retries, fallback paths, or security-related events. Also, don't instrument every single method because that really happens a lot. So you need to focus on something that's more important or meaningful, like inbound requests, like HTTP calls, or outbound calls, like for to database caches, messaging queues, or even business critical operations. Right, and also instrument frameworks and libraries because that will help you along the way. But most importantly,
don't panic because, like I said, especially like the OTel communities around Java, there's a lot of, I would say there's a lot of love around it. And OpenTelemetry itself is a very supportive community. So for example, if you get signed up onto CNCF Slack, you can join any of the OTel channels on there. It starts with OTel Dash, and you can ask a question on there. There's been so many instances, even preparing for talks, where I've gone and, hey, I want to understand this concept a little bit better. You ask a question, no one is a jerk. Everyone is usually super helpful in terms of answering those questions. So you do have the backing of an entire community to help you as well. Now, I did mention earlier that, use AI as your buddy. So the question is, how do we use AI to help us when it comes to instrumenting your code? And I wish that I had that sort of thing back in the day when I was coding, back in the early 2000s. And certainly even when I was getting started with OpenTelemetry, to have something help me instrument my code. And so here's some tips for instrumenting with AI. First of all, ask it lots of questions. Don't be afraid to you provide a situation, provide plenty of context, give all that information. It'll probably spit out some response, and then keep asking it questions. Well, what about this? What about that? That's super important. Challenge your AI. If it makes a suggestion, don't be afraid to question why it's doing that. AI can be really cheeky. Sometimes I like to gaslight my AI, where I say things to it that are untrue. I'm like, well, you told me that a span is the same thing as a metric, and then it'll correctly no, actually it's not like that. And I think it's important to do that because it keeps AI on its toes, because otherwise it likes to please us, and that sometimes doesn't give us good results. Also verify. Now, one interesting technique that a few people have tried out that I think is kind of cool is, you can write your, get AI to help you instrument, and say get Claude to instrument your code, and then get ChatGPT to verify what Claude came up with. So then they can bicker at each other, and that gives you different perspectives. And then, of course, iterate. We are developers. The first solution is a solution, but it might not be the best solution. So keep improving as you're going along.
Yeah, and here, like, I could share some of my journey with AI because I'm not a software developer. Like I said, I come from a different background, like SRE. So yeah, I did challenge my own AI into vibe coding my way through this the demo and obviously this talk. So yeah, I didn't know that Java was like super mature, in instrumenting, and the others weren't. So I tested my way with a bunch of SDKs, and it was a very nice journey, also full of challenges, and we'll get to that a bit later. Yeah, so obviously we have all these cool observability tools around us, right? And we talked about some instrumentation tips, but that's only part of the story. So what do we actually need? We need also help to visualize our telemetry, right? And we need something super, super easy, right? Like an easy button we can press, and we can start to, set it up, understand, and maintain everything. Yeah, so because we are like lazy developers, what would be the perfect OTel workflow for us? So suppose we have an application, we send the telemetry data to the OTel collector. It's configured through a configuration YAML. Great. We can use the collector's debug exporter to print telemetry to the console, but yeah, it's not really that great because it's hard to read. Okay. What else? We can also use the OTel vendor backend, so the ones that you guys have there.
And we work for different OTel vendors,
Yeah,
so but we want you to get started with OpenTelemetry and not be overwhelmed.
exactly. So basically, what happens is that you need to learn that tool, right? So you need to learn to operate with that specific backend. So that also implicates you need to watch out for the learning curve. But also you might not have access because of licensing issues. Also, that happened to us. So maybe not such a great idea also. So the perfect way, I think the ideal solution would be to have a lightweight viewer and not a big, huge setup. So, for example, if we get into OTel configuration right now that you can see, this is partial, you can see more later, we can focus on the debug exporter that will print the telemetry signals to the collector's console. Then to the receiver that will ingest application telemetry. And here we don't have the processors because we're not transforming our data. So yeah, there's no need for it. And also very important, the service, right? Because it connects the receivers, the processors, and the exporters together. So we need one for logs, one for traces, and one for metrics. But yeah, bear in mind that the collection alone sucks for troubleshooting. So we went out there into the world and we started to look at some specific tools. Obviously, there are a lot more, but these are just a few examples for us that we wanted to dig in. So something really cool is called OTel Desktop Viewer. We'll go into deep dive into all of them. OTel Front, OTel TUI, and obviously some ID plugins. So for the OpenTelemetry desktop viewer, actually this is a tool for receiving OpenTelemetry traces while working on the local machine. So you can scan the QR code if you are interested. That will take you to the GitHub repo. You can learn more about that tool. And the next one will be actually it's a tool that's inspired by the previous one, and also it's a terminal OpenTelemetry viewer. The same, you can view the repo there in the QR code. And Autofront we stumbled upon by accident, which was a very nice surprise. And actually, it's a fresher tool. It's a lightweight open telemetry viewer for local development, and you can view not only traces but also logs and metrics instantly. And not the least, we tested JetBrains OpenTelemetry plugin that's available in JetBrains Rider. It supports viewing traces, logs, metrics, and the app architecture, but is for .NET only. Sorry, Java lovers. Anyway, so this is a screenshot for the plugin, for the OTel plugin from JetBrains Rider. Yeah, I had a .NET application, and yeah, down there you can see the plugin that is being installed, and you can view nicely the trace. But yeah, just this is a preview because we didn't focus on .NET, we focused on Java. So yeah, now what?
Now what? So we're going to give you a demo. It's going to be a live demo, so pray to the demo gods that this works out. This is an offline demo, so at least we don't have to contend with like internet connection issues. The demo is simple. It is based on a Java roll dice app from the OpenTelemetry docs. And all it does is we have a server, there's an endpoint called roll dice. The client calls that endpoint, it rolls a virtual die and gives you a number between 1 and 6 and displays it on screen. And specifically, our setup is going to be instrumenting our client and server using OpenTelemetry, sending the data to our OpenTelemetry collector, and then the collector will send the telemetry to 3 of these desktop tools at the same time. So OTel Desktop Viewer, OTel TUI, and OTel Front. And this just highlights the power of the OTel collector because it allows you to basically send your telemetry. It's the same telemetry to 3 different telemetry backends at the same time. And so it's interesting to see how each of them renders the same data differently. And a little bit related to my talk later on today on OpenTelemetry vendor neutrality, if you're interested. And we're also sending the telemetry to the collectors standard out using the debug exporter. So that is the setup. And now we are going to venture into demo land over here. If I can get my cursor to the right spot. There we go. Okay, here we are. So this is the demo. And basically, what I have is we have the OpenTelemetry collector configuration file. Ooh, that's tiny. Let me make that a little bit bigger for everyone.
Is it okay like this?
I can't see
or bigger?
Hang on.
Yeah.
I just need to pull this down. It's really
yeah.
awkward, like trying to do this looking over to the bottom monitor. Okay, this is the OpenTelemetry config, OTel collector config. And as you can see, similar to what Diana showed you, we have our debug exporter, we have our verbosity detailed. So this is like basically in a debug log level essentially. And then we are running the 3 tools in Docker containers. So I have a Docker Compose, and so we're referring to the endpoints here based on the service names in Docker Compose. So this is an exporter. This is OTLP exporter, that OTLP format from OpenTelemetry. We have the OTel for the OTel Desktop Viewer. This is the configuration for OTel TUI, and then the configuration for OTel Front. These 2 are HTTP, and then this is gRPC. So the OTel collector can ingest and export in both HTTP and gRPC. And then, as Diana mentioned in the earlier, we also have these pipelines that we have to define, because it's one thing to define our exporters and our receivers and our processors, but we have to string them together with a pipeline. So what we're doing here in the service section, we have a traces pipeline, a metrics pipeline, a logs pipeline. You can get really fancy with your collector configurations, but this is simple. We want simple. We want to make it easy to develop with OpenTelemetry. So as you can see, as Diana said, the OTel Desktop Viewer does not only is supported for traces. So I've only put it in here in our traces pipeline, and in our metrics pipeline, and logs pipelines, we also include OTel TUI and OTel Front. The other thing I wanted to mention is I did have deep conversations with AI on some of this stuff. So, for example, I wanted to, this Java application, it was just zero code instrumentation. So I talked to AI and I was like, hey, I wanted to add some more OTel traces to my Java server. Can you make some recommendations? And keep in mind, I already have auto instrumentation. So then it gives me all this stuff. I'm like, yay, awesome. Go and add that in. And then later on, I go and say, you know what? I want to actually modify the role controller. That's our kind of that's what's responsible for rolling our die. I want to say, hey, I would like to actually, every time we roll an even number, I want to throw an exception. great, so let's go and throw that exception. It gave me like all the stuff. I said, great, do it. But what it did was it created an illegal argument exception. I'm like, I want a little more specific exception, so create me an even role exception. So then it went and did that, and I did a little bit more iteration. Like, for example, once it initially, when it caught the exception, it rethrew it. I'm like, no, I don't want you to rethrow it, just catch the exception. I want to create a span around it. Can you give me some recommendations on it? Do you think it's a good idea? So that's basically my conversation with AI to help me instrument this Java code. And honestly, I haven't touched Java in a really long time also. So initially, this example wasn't working for me. And I said, you know what, can you give me, can you just fix my Gradle file? I don't know what's wrong. It's not working straight off the example. Fix my Gradle file so this thing will build. And it did that for me, and it was lovely. So enough of that. Let's actually go ahead and run this. So I have the OTel collector and the 3 OTel tools running in Docker. So like I said, I have everything in Docker Compose. We've provided the link to this repo if you want to play around with it earlier, but also it'll be in the references section. But let's start up the OTel collector. And this is the OTel collector starting up. And you can see it's got a bunch of, a lot of logs that it spits out, which is awesome. Not great for debugging, to be honest, but hey, it's a starting point. Next, we're going to start up the OTel viewer over here. So again, it's containerized, and I'm going to just do a Docker Compose up, and I'm going to start up OTel TUI as well. And I have to start it up in daemon mode because this one is a command line, a graphical command line tool. And you'll see why. So there we go. That's OTel TUI, and then we're starting up OTel front next. And so we've started that out, and now we can start up our server and client Java programs. So started that up, and now let's hope that these things work. So let's start with OTel TUI because we should start seeing the telemetry. And as you can see, look, we're already getting telemetry. You see over here we have an exclamation mark, and remember I throw an exception every time there's an even role, and that's represented here in our span. So the exclamation mark says we have an error span, which is really cool. So if I hit D, we can go to details and we can inspect. We can see the various attributes. Some of these attributes are standard attributes. So back to those semantic conventions that I was talking about earlier, these are standard things. I didn't add most of these attributes. If we tab over, we can see various metrics. So a lot of these, because we're doing the zero code instrumentation, there's a bunch of JVM metrics. That's all captured because of the zero code instrumentation, which is really cool. And then there's a bunch of, it's probably hiding somewhere, but there's some metrics also that we defined here in this code, which are hiding, so I'm not going to try to hunt for them. And then we've got our logs as well. So we can see our logs, and you can see the body, and you can see, I also, bonus points if you picked up on the Star Trek references. But you can see the log message body, and then, oopsie, and then you can also see the details of the log over here. So logs come with attributes, more semantic conventions. And then finally, OTel TUI has a nice little feature here where it shows your topology of your application. So we see our client, we see our server, and we can see how many calls have been made from our client to the server, which is really cool. And all the client is doing is just on an endless loop, making calls to our roll dice endpoint on behalf of different players. Now, that's cool. Let's go look over at our other front ends. So here we go. And we are going to look at, this will be OTel desktop viewer if everything works out well. Yes, this is OTel desktop viewer. This is the traces only. This is probably the oldest of the tools. This came out a number of years ago. And it's really cool that you can see, you get a nice little visualization of the traces. OTel TUI has that as well. I forgot to show that part, but it does have that. And these are the different spans that make up your trace. So you click on a span, and it shows the different attributes for your span data. It's got this thing called events. There are no events for this guy, but there are 2 events here. And if we go over here, even role detected, and it tells us, and there was an exception, so you get to see the stack trace. But as Diana said, this only does traces, so not super useful to us. And then finally, we have OTel front, which I mapped to port 8001. They both use internal port 8000, but because of the port conflict, I mapped one to external port 8000, the other one to external port 8001. All that is in the code as well, if you want to check it out. And this is OTel front. It said OTel viewer. It was like, yeah, and this one's cool. It has like this little dashboard that shows total traces, total logs, total metrics, total services. The only thing that's kind of sucky is I'm clicking on this and like, I want to click on these things and it won't let me. But it's nice to have like a little dashboard here. If you want to go into things individually, and also this is the configuration here. So these are the configurations that you need to add to your application to get that to work. Now, so this is the traces view, and you can see the different traces. So if I click on one of these, you again see that trace view, and so these are the individual spans, and you click on that. It's similar to what we had with the other tools, right? Where we have our attributes, and our events are basically essentially logs embedded within your spans. And then this also shows the related logs, which is really, really cool, because now you can see the logs associated with your traces. And Java does a really nice job of associating the logs with the spans. So we didn't even have to do anything super special about that, which is awesome. And then if we go to the logs again, we can do a search on our logs. We can filter on severity. So for example, we can see our error logs, and these are all the ones where we got an error. And if we click on view trace, it takes us back to this page where it shows you the log with respect to the trace. And then finally metrics. This one's cool. Be able to see the metrics. And this is one of the metrics that we manually added to the application, dice result distribution. So if you run this, you can see that. And then you can also add dice rolls. That's another one that we added manually to here. So you can see the average of your dice rolls, and this doesn't clear. So every time you run this, it just keeps adding. So you do have to like click the X every time if you want to clear the screen. But that gives you an idea of basically the different tools at our disposal. They're not perfect. They do have some of their shortcomings, but they are open source. And I would say it's a great way to get started in terms of just having that observability with your application. Okay, let's go back to just wrap things up, because we are running out of time.
Right. Yeah. So that was basically that was like our journey through OpenTelemetry instrumentation. So yeah, let's do a short recap. Yeah, there are so many tools out there, like we've seen, but obviously they come with their challenges. So we need to learn about those tools, right? We have some surprises along the way. Might be that they don't have they're not very well documented, so it takes some time to get there. They also assume that we know how to use Docker, and they might not really work as advertised. Obviously, there are third-party tools, and which means that there will be somebody there out there, like a third-party maintainer, that we are depending on them and their work.
I will also say, though, if it is a tool you like, be kind to your open source maintainers and contribute as well.
Yeah, that's it. Also, these kind of like third-party tools, they really are not in sync with the current state of OpenTelemetry community. So sometimes you'll see things that are like way outdated. So yeah, there are some reality checks out there. Also for instrumentation, like we've seen and we said before, different languages have different levels of maturity. Yeah, and from my personal experience, I did want to go through the SDKs, and I did want to learn like what's what with different programming languages. It was a hit and miss,
You cried with Python.
Yeah, I cried with Python. In the end, I gave up. So I took a repo, Adriana's repo that worked because it had logging there integrated as well. So I was like finally happy. But the rest, like I actually learned quite a lot, and vibe coding helped me along the way too. Yeah, so zero code instrumentation is unfortunately not available universally, and yeah, the initial setup can be tricky. But you know that many teams create their on OTel wrapper. So you know why right now. What else?
But we don't want this to discourage you from instrumenting your code with OpenTelemetry and using it to debug your code locally, because we wouldn't be here if we didn't see the value in it. But we also want you to be aware of what some of the shortcomings are, just so that you know what you're getting yourself into. So, in terms of like when you're debugging your code with OpenTelemetry, I mean, if you've debugged code, you usually have a pretty good idea of what you're looking for. Obviously, look for errors. Some of this tooling makes it easy for you, like we saw with OTel 2e, where it shows the exclamation marks for error spans, filtering on errors. Those types of things are always helpful. Look for latency. As a developer, you're probably not super concerned with like most of the metrics for your application, but one that you probably care about is how long a span takes, especially if you notice, hey, I've had 100 calls to this service, and the span was like, 3 milliseconds, and all of a sudden it's like jumped up to 10 milliseconds. What's up? So that sort of thing, looking for those types of patterns, can help you catch those latency issues before they become a problem in production. Become besties with AI. AI is here to stay, whatever your opinions of it may be, but it is a useful tool. I wish I had that when I was starting out my career. It's cool that Diana, coming from an SRE background, was able to leverage AI to vibe code her way into instrumenting with OpenTelemetry. So I think it is a very useful tool. It does involve a little bit of work, and there is a bit of a learning curve, but super useful. And of course, iterate, iterate, iterate. And remember to reiterate the points. Observability matters for developers because it reduces debug time, it accelerates development, improves our code, and helps us understand distributed systems. But most of all, we've been doing this forever. As developers, we've been adding logs to our code. We have been reviewing stack traces. We have been using profiling tools. So we have been doing observability. Now let's make the standard OpenTelemetry work for us and leverage the tools that are available to make it work for us even better. And with that, we leave you with some references, the GitHub repo that I showcased in the demo. Diana also has a GitHub repo where she played around with that JetBrains tool and examples in different languages. If you're wanting to learn more about observability with OTel, I have an O'Reilly video course on that if video is your jam. Link to the OTel language APIs and SDKs. I mentioned I have a podcast called Geeking Out. The logo is a capybara. And I've had some cool people actually from the Java dev space, including Ishel Ruiz and also Aisha Lafia from the observability space. I've had Liz Fong Jones, Charity Majors. I've had Kelsey Hightower of Kubernetes fame, and most recently I had Scott Hanselman, and Diana has been on my podcast. And Diana, you have a podcast.
Yeah, it's called Devoxx Podcast, Devoxx Talks Podcast. Yeah, we're already starting it. We have like 4 episodes. It's vendor neutral, and mostly we talk about open source or cloud native, but we also go into other topics as well. So if you have a cool idea and want to talk at our podcast, yeah, feel free to reach out.
Definitely, and thank you. Thank you for
Ευχαριστώ.
sticking around, and enjoy lunch.